Today's lesson is on absolute value inequalities. So we want to review interval notation, which represents the set of all real numbers between two endpoints. If you need to include the endpoint, then use a bracket. If you do not need to include the endpoint, then use a parentheses. Also, if the interval continues to positive or negative infinity, then you use a parenthesis symbol. We always write the interval notation as follows: the lowest value, comma, the highest value. So I'm going to give you the inequality notation on the left. I want you to graph it and get the interval notation. So if x is less than a, that requires an open circle, and x is going to the left. So the interval notation is negative infinity on the left, which means you use a parentheses, all the way up until a. We use a parentheses on the a because you cannot include the a. The next one says x is greater than a, so we have an open circle on a, and this time it's going to the right. So the lowest value here is a, comma, the highest value is infinity. Again, they both get parentheses because you always use infinity, parentheses with infinity, and you cannot include a because it's not or equal to. On the next one, it says x is less than or equal to a, which means we have a closed circle here, and x is less mean left to the left. So we start from to the lowest value, negative infinity, up until the highest value, which is a. In this case, I can use a bracket because I'm allowed to include a, because it's or equal to. On the next problem, we have x is greater than or equal to a, which again is a closed circle, but this time to the right. The lowest value I can go is a, comma, the highest value I can go is infinity, and I get to use a bracket on the a parentheses on the infinity. Next, we have some compound inequalities. A is less than x, which is less than b. So a and b can both not be included, and the x values are somewhere in all between a and b. So the interval notation is a, comma, b. They both get parentheses because you cannot include either a or b. Now this is one that's a little bit funny because sometimes this a, comma, b, when they're numbers, looks like an ordered pair, like 3, 7 or something like that. You just have to use your context clues to make sure that you know it's an interval because we're talking about things with intervals rather than an ordered pair. Okay, so that one's a little bit tricky. On the next one, we have a is less than or equal to x, which is less than or equal to b. A and b both get closed circles, and your values are between them. The lowest value you can get is a, which is the lowest endpoint. The highest value is b, and we get both brackets. On the next one, a is open and b is closed. So my interval notation is a, comma, b, with a parentheses on an a and a bracket on the b. And then the next one we have closed on the a, open on the b. So we have the bracket a, comma, b. B has parentheses. Now all real numbers means it has no endpoints on the left and it has no endpoints on the right. We have values everywhere to the left and everywhere to the right. So the interval notation there would be negative infinity to positive infinity. And then for no solution, you wouldn't have any values here at all. So there is no real interval notation for that. You can just use that symbol if you would like for no solution. And again, there would be nothing plotted on the line. So let's review solving linear equations. The only special thing that you probably need to remember here is you can only switch your inequality sign when you multiply or divide by a negative. That's something that you need to remember. Or if you want to rearrange the equation, and I'll show you an example of both of those right now. So on this first example, if I subtract 3 from both sides, notice I don't change my sign because I didn't multiply or divide by a negative. I just subtracted. I can subtract and add all day long. But on the next step, when I divide both sides by -4, because I'm dividing by a negative, not because there's a negative in the problem, but because the operation of dividing, the negative is on the bottom, that means I switch my signs. So this leaves me with x and negative 6, and instead of a less than symbol, I get a greater than symbol. And that would be an example of when we switch the signs. Just to go ahead and finish this off, if I were to graph this, I'd have a closed circle here. X is greater than negative 6, so it has to go to the right. And my interval notation would be bracket negative 6 to infinity. The only other time you'd switch your inequality is if you want to rearrange the equation, which I'll show an example here. Negative 2 is less than x. Is a fine solution. It's just sometimes it's hard to graph when the x is in the back and not in the front. So if you choose to put the x in the front and the value in the back, well, your absolute value sign still has to read correctly. I'm not sure if you guys remember this. Remember the alligator? Okay. The original problem said negative 2 is less than x, which means the alligator is eating the x. There's my little teeth. So if I switch it around, my alligator still needs to eat the x. So this is one case where you could switch your inequality. The only other case is if you multiply or divide by a negative. Now, the reason I like it in this manner better is that when I try to graph it, x is greater than negative 2. Another thing I can do is I like that inequality symbol kind of looks like an arrow, so it should follow an arrow. See how these kind of are both arrows? The inequality and the arrow should point in the same direction. That's one thing I like to use, but that only works if the x is in the front. My interval notation is negative 2 to infinity.